Hey guys, so welcome to our first video lesson. Before I get started, I want to lay out some ground rules that you should already be aware of if you read the email that I sent out regarding the expectations for class for the next couple of weeks. First of all, you need to make sure that you read through the document very carefully and that you are aware of where things are to be located. Not a lot has changed. You still have your unit calendar, which we will be following, and you still have your homework tab. One thing I want to make you aware of is the fact that we will be on semester 2 schedule. So I sent my semester 2 schedule for all my math classes in that email, so please make sure you take a look to see when you have math applications. Okay? So it's important that you do check this video tab every single day. If you look at the video tab and you realize that there's no new video for the day, that probably means that you don't have a video lesson. You have instead some sort of assigned reading or an activity that I put on the relevant tab for the topic of the day. You will know what topic we're studying if you follow the unit calendar, okay? All right, so I hope you guys are well and you're staying healthy. I want to start today's class going over some of the geometry review that you guys have been working on. Several of you have asked questions, and I promised that I would get back to you about the answers to these questions. So let's get started here. So this first question says, a tool shed with the dimensions illustrated is to be painted with 2 coats of zinc aluminum. Each liter of zinc aluminum covers 5 meters squared and costs $8.25. It must be purchased in whole liters. So there's a lot to unpack there. So one of the things that you might not have been aware of if you got this question wrong or that you just glossed over was the fact that it needs 2 coats of zinc aluminum and that it needs to be purchased in whole liters. Remember, this is called applications and interpretations, so you need to make sure that you are reading each question very carefully and that you are highlighting, key terms and important parts of the question that might cause some issues. So to get this question correct, of course, we're going to have to figure out how much paint we need. So we need to find the surface area of this figure, knowing, of course, that the base of the figure is going to be on the ground, and so that will not be painted. So what I did was I started by finding the surface area of the base. So that's going to be 2.5 times 3, and that is going to be multiplied by 2. Because, of course, you've got this front facing rectangle, and then you've got the back side. All right. Now we need to take into account this part here. So you've got that 5 meter length, and you've got the 2.5 width, and you've got 2 of those, of course, so you're going to have to double that. So that's 5 times 2.5, and then you're going to have to double that. So that is the base of this structure here. So to that, we're going to add the top, so that triangular roof part. So let's go ahead and do that. So for the top, we've got that triangle. So we've got 1/2 times 3, so that's the base of that triangle here that I'm working with. I'll highlight that for you right there. So 1/2 times 3 times 2, that's the height, and then you've got 1 on the other side, so you have to double that. And then you add to that 5 times 2.5 times 2. So again, I had to look at this rectangular face right there, and I've got 2 of those. So when I add everything together, I get 71 meters squared. Now I would assume that most of you got this. It's not too terribly difficult. Just add the base and the top. Now, the next part I think can be confusing if you did not read the question correctly. So that's the surface area, but because we have to paint it in 2 coats of paint for part B for the total cost, we're going to have to double that. So what we're going to do is we're going to take that 71 meters squared and we're going to go ahead and double that to get 142 meters squared. And that's because we need 2 coats, okay? Now, every liter covers 5 meters squared, so it's very simple. From here, you get 142 meters squared for the 2 coats of paint. You divide that by the 5 meters squared, and you get 28.5 liters that are going to be needed to cover this figure. However, the question also says that it has to be purchased in whole liters. So you're going to have to round up, and you get 29. 29 times that 8.25, that's going to give you the 239.25, which is the correct cost. Okay, so a lot to unpack here with this question. You need to make sure that you read the question carefully, and that can be kind of tricky, especially if you're under pressure. So make sure that you're looking back at the question. I guarantee you that you know what you're doing. You know how to solve this question. It's just probably something embedded in the question that you're just missing. Okay, so let's move to the next one. All right, now this question was tricky. Honestly, when I did it the first time, I did not get it correct. And I think it's because when you see a figure like this and you see that apex, the apex is the very top of the pyramid, it can be kind of confusing to figure out what this aspect of the problem is identifying. So I'm going to tell you how this problem works, and hopefully as I go through it, you're able to see sort of the figure that I draw in your head, because a lot of this is spatial reasoning. And if you don't, I would encourage you to pause the video and go back and try and process this maybe at a slower pace. But yeah, this was a very tricky question. So this asked for the volume of the pyramid. And if you remember from your formula booklet, if you don't know, the volume of the pyramid is 1/3. So I'm going to write this down. It's 1/3 times the area of the base times the height. Well, the area of the base is simple. It's a square base, and so we've got 12 meters. 12 by 12 is 144. But the height is what is challenging here. So let's go ahead and draw the height. Well, in order to understand this first, actually before I draw the height, I'm going to draw the diagonals of the base. And you'll see how that helps us in a moment. So I'm going to draw the diagonals of that base. And then what I'm going to do from there is I'm going to draw the height. So I'm going to try my best here because, I'm not drawing with a straight line, but okay. So we've got, see if this highlighter is going to cause any problems. We've got this triangle right here that I've highlighted in red, where that's the height. We also know that we have a right angle here. Okay, so somehow we need to be able to figure out the height of this triangle. Well, we're going to be able to do that using trig. And you might be wondering, okay, well, even if we, find this side, which I'll call that x, how do I don't have enough information. Well, that's where the 80 degrees comes into play. Because what we really have is we've got this triangle. So let me draw. Let me erase this. I'm using a new application here, so if I'm a little slow, just forgive me. So you've got that right angle, and this is that diagonal, and then you've got the height, and then you've got that 80 degrees. Now that 80 degrees means that that's 40 degrees and that's 40 degrees. Now you might be wondering, okay, Miss Nguyen, what triangle are we talking about? Well, we're talking about that triangle right there, okay? So I've already labeled one of the x's for you. I've already labeled the height for you. That, don't want that. Let's erase this here. Here we go. And so that's x as well. And then this is 40 degrees, and that's 40 degrees. Okay? Do we have any questions about that? Well, if you do, send me an email or rewatch this part of the video. But now we've got something that we can really work with here. All right. So I need to find this pesky x. Well, you might be thinking, with this triangle here, we have two unknowns, so how can we do that? Well, the key there is recognizing another triangle. Now, if you remember the properties of a rhombus and its diagonals, what do we know? Well, we know that here, we know that all of the sides are 12 meters. The diagonals are going to bisect each other at right angles. So that actually means, even though it doesn't look like it, each of the diagonals is x, and they're all cut at a right angle. That means, so bear with me here. So see this triangle that I'm highlighting in black? Well, we know that that's 12 meters. And we also know that this must be a right angle because the diagonals, they bisect each other and they're cut at a right angle, right? So, if you don't believe me, you can always look up the properties of your diagonals for this figure, but you'll realize that they are cut at right angles, and those have to be all x, right? So, what can we do? Well, now we've got another triangle. We've got lots of triangles here. We've got that triangle that I just drew. It has x and x. That means it's a, 45, 45, 90 degree triangle there. And it's got that hypotenuse of 12 meters. Well, now we can simply use Pythagorean theorem to find x, right? We can take x squared plus x squared, and we can set that equal to 12 squared. Well, that's 2x squared is equal to 144. We divide that by 2. We get x squared is equal to 72. We take the square root. We don't have to remember our negative because we're dealing with distance, which is always positive. So we get square root of 72 meters. So part of that diagonal is square root of 72. So we know that value of x. We know this value of x is square root of 72, right? So now we can use what we know. We've got that 40 degree angle, we've got that square root of 72, and now we can find the height. So let's go ahead and do that now. So I'm going to draw that triangle. Got that 90 degrees, I've got that height, I've got the square root of 72, I've got the 40 degrees. So what would I do now? Pause the video and try to figure it out yourself, and we'll see if we get the same thing. All right, so did you end up with 10.1 meters? Hopefully. So now we've got everything that we need, and we can finally find the volume of this figure. So go ahead and do that and see what you come up with. All right, so 144 times a third times 10.1 is approximately 485 meters cubed. Don't forget to round to 3 sig figs, and don't forget that it's units cubed because you're calculating the volume. So I hope that was helpful, and I hope you were able to visualize this. Something that helped me, the first time I got this wrong, I actually cut out a net of a pyramid, and I was able to see how to visualize this problem. So I would encourage you with any of these three-dimensional problems, if you're having a hard time, just hang in there, because spatial reasoning takes a lot of time to develop, but also try different strategies. Just search for the net of the figure that you're looking at, cut it out, tape it together, and see if that will help you visualize the problem a little bit better. Okay, so we've got one more to do, and then we'll be done, and I'll let you know what your task is for today. All right, a bearings problem. So a student asked about this bearings problem. It's a very interesting one, and actually something that is very relevant to you, because I have seen this type of question asked multiple times on IB exams. So, make sure that you understand this. In fact, it was on my grade 12 mock exam, because that was given in November. They had a question that wasn't exactly like this, but was very similar. So let's walk through it and make sure that you understand what to do. There are a couple different ways you can do this. I'm going to demonstrate the way that I think is the most direct and the most time-saving, and one that will allow you to use your graphing calculator to quickly solve a question like this. So it says a boat was supposed to be sailing directly from A to B. However, it traveled in a straight line to C before the captain realized he was off course. He turned the boat through an angle of 60 degrees and traveled another 10 kilometers to B. The trip would have been 4 kilometers shorter if the boat had gone straight from A to B. How far did the boat travel? So just like that painting question that we took a look at in the very beginning, you need to make sure that you are not forgetting about important information in the problem. What I mean by that is this piece right here. The trip would have been 4 kilometers shorter if the boat had gone straight from A to B. So we don't know how long or how much distance-wise he traveled from A to C. So we're just going to label that as X. So we know that if you add the distance from A to C and the distance from C to B, you get X plus 10. Well, what's 4 kilometers shorter than that? Well, that's just X plus 6, right? And what I notice about this triangle, first of all, is it's not a right triangle. So I'm not going to be using right triangle trig necessarily for this. I might have to be using my laws of sines and cosines and combining that with bearings. So let's go ahead and do that. What I'm going to do, first of all, is I'm going to draw that compass rose. Remember, we start from true north with our true bearings here. So I'm going to just draw this in the best that I can. That's true north. Okay. Well, hopefully we can start to see a few things here with regard to the diagram. So let me draw this a little bit better. Okay. So we know that that's 30 degrees. How do we know that? Well, from true north to that 10 kilometers, that's 90 degrees altogether. We already know that there is a piece of that where he turned 60 degrees. He turned through an angle of 60 degrees, so that other missing angle is 30 degrees. We should also be able to determine that we have vertical angles. So we've got 30 degrees. So we've got those vertical angles there. What else do we know? Pause the video and see if you can come up with a complete picture of this diagram. All right, so you've got that 90 degrees there, you've got 30 degrees, so you've got that angle, that this obtuse triangle that has that angle at the top left corner as 120 degrees. Now, here's the trick to this. What law do you use? Well, looking at this, we've got that angle, we've got those two sides, so I'm going to actually be using the cosine law here. If you don't remember which laws to use, go back on the notes, look at the law of sines and law of cosines, and remember, which ones did I say where you would use the law of sines? Was it side, side, side? Was it side, angle, side? Or was it angle, angle, side? You know, if you know that, that's really going to save you some time thinking about which law that you have to use. That's more of that conceptual understanding that will really help you be efficient when you're solving these questions. So I'm going to go ahead and set up this problem. Again, this was very similar to the mock exam that I gave, and a lot of my students for the grade 12 cohort, well, not a lot, a few of them missed this question. So I don't want you guys to do the same thing here. So we've got cosine of 120 degrees. Well, that's going to be equal to x squared plus 10 squared. I'm just following the formula if you're wondering what I'm doing. Minus x plus 6 quantity squared. Remember, you can use that formula booklet, although it always helps if you understand these formulas without having to refer to the booklet. But, you know, don't overstress about that. I would rather you understand the concept. And then divide that by 2 times x times 10. Wow, how do we solve that? Take a moment and try and figure out how would you solve for x here. There are multiple strategies. You might be doing something different than I do, but just take a moment, reflect, and think about how you would solve this. Pause the video, try to solve it, and see if you get what I get. All right, so x is equal to 32 kilometers. How did I do that? Well, NSolve. NSolve is what I did here. Now, NSolve is something that can definitely get you out of a sticky situation. The only time I would avoid NSolve is if you're dealing with a quadratic that has two answers. Now, you might be saying, well, Miss Nguyen, this is a quadratic and there are two answers. However, you know that you're dealing with distance here. And because you know you're dealing with distance, you're going to throw out that negative answer anyways, if there is a negative answer there. NSolve, sometimes they'll give you just the minimum answer. If there are two answers and you've got, maybe one's 50 and the other's 150, maybe it'll just give you 50. But on these types of questions, on all of them that I've seen under the IB question bank, they rely on NSolve to solve them. So I would say if you see a question like this and it's just too difficult to solve, try NSolve and see if it makes sense. If it doesn't make sense, then, graph the function and set it equal to 0, find the roots, and see if that will make sense. Of course, there are more than one strategy, but NSolve is something that will work best. Be warned, however, that when you're doing NSolve with this, that you have to be very, very careful with how you plug it into your calculator. If you are missing a parentheses, if you typed something wrong or you forgot a parentheses, your calculator is going to say most likely that you are missing some command. So if that's the case, look at how you typed it. Maybe you're missing a parentheses and retype it and you should get 32. Okay, if you're not getting 32, just carefully examine what you may or may not have done correctly. Okay, so that means how far did the boat travel? Well, that's just 32 plus 10, which is 42 kilometers. All right, so those are all the questions that you guys asked me for those 2 days that we worked on the review. If there are other questions, feel free to send them to me. I might not be able to get to them right away because I've got a lot to do during this extended holiday. But some things I want you to be aware of. Your assignment for today's class, is to work on the SAT Geometry Review. You can find that on your homework tab. So that's Monday's assignment, Monday, February 10th. That's the assignment due on the 11th. Please upload that under your homework tab for SAT Geometry Practice. I put that tab in for everyone. So at the end of the week, I will check everyone's homework tab and I will make sure that everyone's caught up. For those of you who are not, If you sent me a message detailing me why with a legitimate reason, then I can, make an exception. But if you did not, I will make a note on Manage Back, and I will, if this becomes, quite a problem, I will make note of that on your report card comments. So please make sure you're doing that. And then on Tuesday, we're going to start our new unit on graph theory. So this is brand new to everyone and something that's unique to applications. So there will be a class video up on Tuesday, and be mindful that I am in America right now. So if you don't see a video, it is coming very shortly, and I'm trying to be aware of everyone's time differences, okay? Well, have a great day. Good luck on the SAT homework. The key is on OneNote. I tried to put detailed answers in, so if you have a question, make sure you take a look at that key. Let me know if you have any other questions. Please make sure, if you haven't done so already, that you looked at that document that I sent out by email detailing the procedures for the rest of this extended break. I hope you're safe. I hope you're happy, and just take care of yourselves, and hopefully I will see you in a month's time or so.